Have you ever wondered how permutation and combination works? Well, we are about to find out. First, I'm going to give you the introduction of PNC. PNC is basically permutation and combination. So, it is one of the most logical phenomenon of mathematics wherein there are no formula to mug up, and it's true. You don't have to learn any formulas. You just have to apply your logical ability to solve any question. And trust me, the difficulty level of permutation combination goes from 0 to infinity. So it depends upon your logical ability. And the more question you practice, the more the more better you become. So do you know what a factorial is? Because before proceeding, you will have to know what a factorial is. Let me give you an example of n factorial. So it is the multiplication of first n natural numbers. This is n factorial. So there are two principles of counting. So this is the topic, fundamental principle of counting. Now you will get to know why I asked you about this term factorial. And okay, before proceeding to the fundamental principle of counting, I'm also going to ask you something. Can you write n factorial as n minus 1 factorial into n? Because what is the n minus 1 factorial? It's 1 into 2 into up till n minus 1. This is n minus 1 factorial, and into n, this becomes your n factorial. Okay, so will you remember this formula? Now, have you ever heard that 0 factorial is equal to 1? So, why is it that? If I convert this 1, okay, can you write 1 as 1 factorial? Okay, we can also write because 1 factorial is 1. So, can you consider 1 as n? N is equal to 1. So, we just studied that n factorial is equal to n minus 1 factorial into n. So in this case, our n is equal to 1. So 1 factorial is equal to 0 factorial into 1. So what is 0 factorial? 1 factorial divided by 1, it is 1. Okay. So this is the mathematical proof of 0 factorial. So what was the point of explaining this topic, like this concept about 0 factorial to 1? Nothing. I just wanted you to know. So we have uh, two principles. One is product rule, and the other is addition rule. I won't take much of your time. Suppose that you are given three operations. The number of ways to perform first operation is x, number of ways to perform second operation is y, and number of ways to perform third operation is z. So number of ways to perform these three operations will be x into y into z. Given that you can perform the second operation only if you perform the first, and you can perform the third operation only if you perform the second. It means that you're performing first operation, then second operation, then third operation. Okay. So the total number of ways will be x into y into z. And I can give you a brief proof for this. Let's say there are a total of x ways, dotted, x ways. This is the first way, this is the second way, third way, fourth way, and up till xth way to reach the first operation. And then you have y ways to reach the second operation. This is your second operation. You can reach in using this path. This is the second path. This is the first path. This is the third path. And this is the yth path. Yth path. Okay. So if you choose the first way, how many ways is there? How many ways are there to reach the second path? One, two, three. There are total of y ways. If you choose the first path, and if you choose the second path, you still have y ways. For third path, you still have y ways. So how many times this y will be added? Will it not be added x times? So y plus y added x times, it means y into x. Now, so we know that there are x into y ways to reach to do operation to do two operations. Okay, and now you want to do the third operation. So third operation can be performed in one way, second way, and zth way. This is the number of operation to perform operation number of paths to perform operation 3. So xy will be added z times. So can I not say x into y into z? So if you are ever given a question that there are m operations, okay, and each operation can be performed in each operation can be performed in n ways. So in how many ways you can perform n m operations? N into n up till m times. So it will be n to the power m. And what if the number of ways were distinct, like A for first operation, B for second operation, C for third operation, and up till like M for the mth operation. Let's say like that. So would it be A into B into C into D into M? Okay. So this is how product rule works. And what is the addition rule? The only difference between product rule and addition rule is that operations are independent in this case. Very important. It means if you are performing operation 1 and then you are performing operation 2, so it's not necessary that you have to perform operation 1 in order to perform the operation 2. It means that you can only perform operation 2, or you can perform operation 1, or you can perform operation 3. Okay, these all are independent. So in how many ways can you perform these operations? So if you perform operation 2, then you satisfy the condition of performing either of these three operations. Okay. Okay, let me give you one disclaimer. Whenever you uh, encounter any question which has the term either, it means it's using the addition rule. Okay. And whenever you encounter any question which is using the term and, so it's there's a high chance that it's using the product rule. I'm not saying that 100% and this fact is true, but in most of the cases you will see. Okay, so if you can perform operation 2 in x ways, operation 1 in y ways, and operation 3 in z ways, then there are a number of ways to perform either of these operations is x plus 5 plus z. Okay, and it's very true. I mean, I don't even need to give you the proof. It's very logical because none of these are dependent on each other. So you will just sum up the number of ways. Okay, so this was our second topic, product rule and addition rule. Now, third topic is, I think, the most important topic, or I can say that it's most used concept in PNC, and it is NCR and NPR. So, what is NCR? Suppose that you are given a group of n items, and you have to r items select r items from this group. So NCR tells you the number of ways you can select r items. And what is NPR? The same example. You are given n items. You have to select r items. But in this case, after selecting those r items, you will also arrange those items. Okay. Arrangement is valid in this case. And in this case, arrangement is not valid. So let me give you a very basic example. Let's say n is equal to 3. Okay, this is the n value, and r is equal to 2, and your item is ABC. Now you have to select two items from the from this word, and I will ask you that in how many ways can you select two words, or you can say two letters from this three-letter word. So one way is to choose AB, the other way is to choose AC, and the other way is to choose BC. Okay, so how many ways were there? Three ways. So there is no other way to choose two letters from this three-letter word. And this is nothing but NCR. But how NPR works? You selected AB, AC, BC, but after selecting, you also permuted it. Okay, so permuted means you also arranged it. Like BC is one way to arrange, and a CB is the other way to arrange it. And had it been BCA, if this BCB let's say that had this BCB BCA, then it would permute or arrange BCA also, and there would be a total of 6 ways. So formula for NCR is n factorial upon n minus r factorial into r factorial, and for NPR formula is n factorial upon n minus r factorial into r factorial. See, up till here, it is exactly same as NCR, because before arranging those uh, two letter word, you have to select those two letter words. Okay. So the number of ways to select the two letters from this three letter word is NCR. Okay. And 3C2. In this case, 3C2. So first you will do that, and after selecting those, you will arrange it. So can I say that number of ways to arrange two letter R items will be R factorial? So for now, if you are not able to understand this, you can just mug up. I will just explain it in the next topic. So NPR is n factorial upon n minus R factorial. Now the question comes, why I'm saying that if there are, why I multiplied it with R? Okay, so if you are given R items, in how many ways can you arrange it? It's R factorial. You can take an example of ABC. In how many ways can ABC be permuted? It's 3 factorial, which is 1 into 2 into 3 equal to 6. And also I can just write it in 6 different ways: ABC, ACB, BAC, BCA, CAB, CBA. So there are a total of 6 ways to arrange it. Similarly for ABCD, how many ways are there to arrange this ABCD? It's 4 factorial, which is nothing but 1 into 2 into 3 into 4 is equal to 24. So if you want me to, give proof for this, you can just comment it. I will make a single video in which I will explain you the proof of each and everything. Although I don't think that it's needed to explain the proof of product rule and addition rule, because I already told you. But I can also explain you in this video about the proof of arrangement. Why it's n factorial or r factorial. Why, if there are r items and the number of ways to arrange it is r factorial. Why is it? I can explain you in this video also. Let's say that you have 4 items, okay, and I want to uh, arrange this. Okay, I want to arrange all these 4 items. So what I can do? Can I say that suppose uh, we have A, B, C, and D. These are our 4 distinct items. So in how many ways can you fill this? You can fill this with A, B, C, or D. Is there any more possibility? No, because we just have 4 items. So I will say that number of ways to fill this is 4. And now I'm going to give you the example of product rule, because we just studied about the product rule, and this is nothing but product rule only. So you can consider it as operation 1, this as operation 2, this is operation 3, and this is operation 4. Okay. If you have filled this box with one of these 4 items, so you had 4 ways to fill. Now, I'm asking you how many ways are to fill this second box. See, you already chose one of these 4 items. It could be A, B, C, or D. I don't know about that, but you chose one. So, how many you are left with? Only 3. So, can I say that number of ways to fill this box is 3 only, because you already chose one here. And similarly, number of ways to fill this is 2, and number of ways to fill this is 1. So you are performing operation 1 and it has 4 ways. Operation 2, it has 3 ways. Similarly, for operation 3, it has 2 ways, and for operation 4, it has only 1 way. So my question is, in how many ways can you perform all 4 operations? And remember one thing, this is dependent, all these operations are dependent. They are not independent. So we are not going to apply addition rule here. Why I'm saying that they are dependent? Because this box is dependent on the previous box. If you have already filled this box with A, then you cannot fill the other box with A. So these all are dependent. So can I say that 4 into 3 into 2 into 1 is the total number of ways? And that's what product rule say. So it is nothing but 4 factorial. So if I give you n boxes, so how many ways will there be? N into n minus 1 into up till 1, which is nothing but n factorial. So I think this is enough for today's class. And in the next video, I'm going to give you some questions. And I don't think that there are much topics left in this chapter. Okay. So thank you and have a nice day.